All right, so today we're going to begin our last chapter, which is chapter 7 on logs. Okay, let me show you an example of an equation you could use a logarithm to solve, or you might be able to get the answer in your head. Okay, it says 2 raised to what power would give you 8? Anybody think they know 2? Yeah, it's 2 to the 3rd power. Okay, and you can get that as long as you know your multiples of 2. Okay? 2 cubed, or your powers of 2. 2 cubed is 8. How about if I did 3 to what? Yeah, let's try that again. 3 to what power would give you 9? 2, yeah, good. And again, as long as you know your powers of 3, you can do that. Okay. 2 to what power gives me 10? What makes that question a little harder than the other 2? It's the same setup. 2 to a power equals a number, but the number I chose on the other side makes this problem harder. Anybody tell me why? Okay, it would have to be, so yeah, it would be some kind of decimal, yeah, or fraction. Because you're saying 2 to what power gives you 10? Well, if you do 2 cubed, that's 8. That's too small. If you go to the next number up, 4, 2 to the 4th power, that's 16. That's too big. So x is somewhere between 3 and 4. Right? What is it exactly? Well, that's where a logarithm would come in. Okay, so logarithms are going to be used pretty much when you have to deal with variables in the exponents. That's when you see logarithms. Okay, let me start out just by defining the thing I just had on the board. That was called an exponential expression. Okay, very simply, an exponential expression is any expression that has a variable in the exponent. This is not an exponential expression. 2 times x equals 12. No. That does not have a variable as an exponent. It has a variable as a factor, not as an exponent. Right? So there's a couple expressions that have variables as the exponent. So what I had on the other page, we could actually say it's an exponential equation. Okay, something becomes an equation once you put an equal sign in it. These are just expressions. There's nothing to solve here. There's no equal sign. All right, so there's going to be 2 different formats we could write things in. We can either write something as an exponential expression, or we can write it as a logarithmic expression. It's 2 different ways of writing the same thing. And in general, that's going to be a big part of what we do this week. Okay, if something is in exponential form, we're going to learn how to change it into a logarithmic form. Or if it's in logarithmic form, we're going to learn how to change it back to exponential. Which way we do it? Well, it depends on the kind of problem we have. Right, so there's a formula to change between the 2. I'm going to show you the formula, and then we'll do some examples. Okay, so that double-ended arrow means you can convert either way. What's on the left? This is an exponential expression. What's on the right? This is a logarithmic expression. How do you know that? The one on the right has the word log in it. That's a logarithmic expression. Right? And there's really 3 pieces of information that we have to look at. You've got the A. Does anybody know, what do you call that number? When you have the number up higher, that's your exponent. But how about the number lower? That's your base. Okay, so A is your base. Y is your exponent. x is what it was equal to. Okay, that was by itself on the other side. Okay, so when we rewrite it in log form, okay, and again, there'll be some numbers in here when we do an example. First thing you do is you start by writing the word log. The next thing you have to do is figure out where does the a go, where does the y go, and where's the x go. Well, notice here how that a is written a little bit lower than the x. It's also a little bit lower than the word log. That's a base. Okay? So whatever your base was in the exponential expression becomes the base on the word log. And in fact, that's how you pronounce what's on the right-hand side. Y equals log base a of x. Read it left to right. Y equals log base a of x. Okay, so whatever the base was on your original, that becomes the base on your log. Okay, so that's where the a goes. Okay, the next thing I'm going to look at is the exponent. When you write something as a log, the exponent goes by itself. So I want you to remember that a logarithm always equals an exponent. In fact, I'm going to write that down. That's important. A logarithm always equals an exponent. That's what a logarithm is. It's used to find an exponent, especially when the exponent is a variable. So a logarithm always equals an exponent. Okay, so if you know that, you take your logarithm and you set it equal to your exponent, okay, which was a y. And now there's only one thing left. There was an x, and there's only one place left for it to go. Right there. That's called the argument. Okay, we've had arguments before. Okay, like when you write down sine of 20 degrees. 20 degrees is the argument. It's the thing that you're plugging into the sine function. Well, x is going to be the thing we plug into the log function. Okay? So on a calculator, you might see something like log of 8. Well, 8 is the argument. It's the thing that I'm plugging into the log function. And if I hit enter, I'll get some kind of answer. Okay, but that's the argument. Okay. So the base on the original becomes the base on your log. Exponent always goes by itself. And then the only place left is to put the x for the argument. Okay, does everybody have that formula? Yeah, we'll try it. Let's try it with some numbers. So what I have up there, that's a logarithmic expression. Okay, it's got the word log in it. And I'm going to change it to exponential. Once you change it to exponential, it shouldn't have the word log in it. That's going to go away. So there's basically going to be three things. You're going to have a base. You're going to have an exponent. And then you're going to have something on the other side. So we just have to figure out where the y goes, where the 3 goes, and where the x goes. Shelby, what's my base in the original problem? 3. So everyone agreed earlier, the base is the number that we write lower. Okay, next I need to figure out what my exponent is. Sam, what's my exponent here?
Y.
Yeah. You know it's y because a logarithm always equals the exponent. Logarithm equals the exponent. 3 to the y. Now there's only one thing we haven't used. Okay, the x, and there's only one spot for it to go. Right there. Okay, so when you write your final answer, you can just write it like this. just put the boxes so you could kind of see where stuff goes. Any questions how we changed from log form to exponential? Now, you can't solve that. If you knew y, then you could. Let's say you know y was 2. Then you could do 3 squared and get x is 9. But without knowing x or y, you can't solve it. Right? Just practicing converting. Right, let's try this one. Y equals log base 5 of x. And just in case, like if you're writing this on paper, let's say you had lined paper. It would be log base 5 of x. That's how it would look. Okay, the 5 is written a little bit lower below the line. It's the base. And the x, that's the argument, should be right on the line with everything else. Okay, but that's how it would look on paper. Okay, Cody, what's my base? What's my base here, Cody? 5. Right. It's the number that's lower than everything else. So we'll have that as our base. Now we got to put an exponent on the 5. Okay, Yadira, what's my exponent?
Log.
Yeah, the logarithm always equals the exponent. And what's going to be by itself on the other side? The x. Argument goes by itself. And that's it. Any question on that? So that's how you change from log to exponential. All right, let's try it the other way. Let's take something that's an exponential and change it to a log. Sarah, what do you think the first thing we should write down is? If we're going to change it to log form. Yeah, we're going to write down the word log. Okay, at least start with that, because you know that's going to be your answer somewhere. And what did you say goes by itself? 3. Exactly. Logarithm always equals the exponent. 3 was the exponent. Next, I need to decide on my base, and then my argument. Tom, what's my base here? Yeah, 1.2. That's the number that's below the exponent. So log base 1.2 of, Brandon, what's the only thing I haven't used? M. That's it. Any question on that one? So where this is eventually going to be used is to try to solve for M or something like that. Let's try that one. E to the B equals 9. Okay, first thing I'll do, write down the word log. Okay, Josh, what's going to go by itself here?
9.
So logarithm always equals what?
Number.
What kind of number?
Oh, the exponent.
Exponent. What's the exponent here?
B.
B. Yep, it's a B. Okay, so we got our B. Now we just need to decide on the base and the argument. Okay, what's my base here? B. E, sorry, yeah, E. And now the only thing left is the 9. Okay, any question on that one? And let's try one more. Try that one on your own. See if you can get that in log form. Figure out what goes by itself, find the base, and then find the argument. How about Andy? What's going to go by itself here?
4.
Yep. Logarithm always equals exponent. 4. Okay, my base. Well, Zach, what's my base?
A.
Yep. The only thing left now is the 24. Good. Any question on changing something that's exponential into log form? Pretty straightforward. There's only 3 things. There's only 3 places for them to go. And if you can remember at least 2 of them, then the third one, there's only 1 spot left. Okay, let's try one more. The same thing we just did. I want to make sure people didn't forget how to do it the other way. Andrew, can you tell me what's my base here? E? What's my exponent?
B.
So,
Negative.
negative 3, yeah. Logarithm always equals the exponent.
I thought you were asking what in that equation. Yeah.
And that would equal B. So remember, if this was lined paper, that B is not an exponent. It's right on the line. The E would be below. Okay. In the original problem, if you had an exponent, it would be something like that. Now the original problem has an exponent of 2 on the B. Okay. Now that's actually something we could type in and get an answer. Okay. Yeah, E. E is a number. Okay. We haven't talked about it too much yet. But anybody know what E is?
MC squared.
E equals MC squared? That is another formula, yeah. Not the one we're going to use here, though. In this case, E doesn't stand for energy, but it actually is, if you press second and press that button, it's the number 2.71, roughly, 2.718. Okay, it looks like it repeats, 1828, 1828, but it doesn't continue in that pattern. It's like pi. Okay, it's just a letter that stands for a number. We use pi a lot more for circles and circumference and things like that. We don't use E as much. Okay, but in logarithms, E does come up. So I'll talk about E in a little bit. So if you wanted to know E to the negative third, you could type it in. The answer is 0.05, roughly. Okay.
So are we going to have to do that on the test?
Yep, there are some you're going to have to do out, but I'm going to explain what E is first. Okay. Before I said that, I bet most people just thought, well, E is just another letter, like he used B, he used E. But E is a special letter with logarithms. You don't need to know that to do anything we just did, though, because you guys just did it, and you didn't know what E was. Okay, but you do have to know how to rewrite it just like that. Okay, so this is what I want to try to solve. Okay, I want to find X. And right now, we only know one thing to do. There are many, many things you can do with logarithms. We only know one. To solve this for X, what can I do to that? Change it, yeah, change it to what? Change it to exponential. Okay, that's the only thing we know how to do. It's a logarithmic expression. Let's change it to an exponential expression or equation. Okay, start with my base. Okay, Naisha, what's my base? 2. Okay. 2. Sean, what's my exponent?
I'm not 100% sure.
So you remember what kind of number? Logarithm always equals
X.
exponent. Logarithm always equals the exponent. So what's the logarithm equal to here? Yeah, it's equal to x. Logarithm equals your exponent. What's the only thing I haven't used? 16. That goes by itself on the other side. Now from this point, we just have to guess the answer. I'm going to give you numbers that will work out nicely in your head for now. Okay, Max, what would the answer be to that?
4.
4. Yeah, 2 to the 4th power. 2 times 2 times 2 times 2. That gives you 16. Now if I made it 2 to the x equals 17. Well,
You know 16.
yeah. Oh, thank you. If I made it 2 2 to the x equals 17. Now it's going to be a harder problem to do. All right, but right now that's not bad to guess the answer in your head. After a while, you can kind of look at it, and you don't even need to do that conversion that we're doing. You're basically saying 2 to what power would give me 16. This is 5 to what power would give me 25. Okay. Without writing the conversion out, anybody think they know the answer? 2. Yeah, the answer is 2. If you did the whole thing out, 5 is your base, x becomes the exponent, 25 goes by itself. Now we look at it, 5 to the second power. Okay, any questions on that when the number on the right-hand side is a power of the base on the left? Okay, for now, that's how we'll keep it. All right, let's try that one. For this one, I think we should write out the conversion. Okay, we'll write it out, and we'll see if we can figure it out. Okay, Ashley, what's my base here?
3.
3? And my exponent?
X.
Yep, x. And the only thing left is 1 over 27. Okay, now from here, there's no more work that you have to do. Okay, we've got to look at that and be able to figure out the answer. Let me give you a slightly different problem. And think about this one. What would the answer to that be? 3. 3 to the third power would give me 27. Well, I don't want 27. I want it flipped. Does anyone remember what kind of numbers, if you put them as an exponent, causes a fraction to flip? A negative, right. So in this case, 3 to the third gives me 27. 3 to the, what do you think the exponent should be? Negative 3. If you make the exponent a negative, that causes it to flip. And it's not a 27, it's a 1 over 27. Okay? And you could easily, if you get confused and you're not sure, check it. Type 3 to the negative third power. See what you get. You get 0.037. Now type 1 divided by 27. See what you got. Same thing. So you found the right number. Okay? So keep that idea in mind. If you want a fraction, your exponent has to be a negative, and that causes it to flip. Okay, so I mentioned earlier this idea already that E isn't just a letter, but it stands for a special number. Okay, the calculator showed a few more digits. And again, it looks like that, 1828, 1828. Sometimes if you see it twice in a row, you might think, oh, that's the pattern, 1828, keeps going, but it doesn't. I don't know what the next digit is off the top of my head, but it's not in the same pattern.
Can you do the calculator?
Yeah. Okay, so where you see E come up a lot of times is in the base. Okay, it comes up in the base of the logarithm. And because it comes up so much, we have a special abbreviation when you see that. Okay, when you see E as a base on a logarithm, there's a shorter way to write it. Does anybody know the short way of writing that out? I mean, that's pretty short. It's only 4 letters, but we can shorten it even more. We use this abbreviation lowercase l, lowercase n. So whenever you have, this is one of 2 special logarithms. There's only 2. This is one of them. Whenever the base is an e, you could write it like this. It's not wrong to write log base e, but generally people use this abbreviation lowercase l, lowercase n. Okay, it's on your calculator. It's usually right near the log button. Okay, if you press the one below it. On mine, it says ln. Okay, let me show you what happens if you type in log base e or you type in ln. It doesn't matter. Okay, if I type in, let's type in log base e of 5. Now let me type in natural log, and I'm going to keep the argument the same, 5. It's the same thing. It's just a shorter way of writing it on paper. Okay, so here's the big idea. Anytime you see log base e, it's the same as writing ln. Okay, and x is just the argument. Like I used a 5, you could use a 7, 12, okay, whatever number you want. Except negatives. We're not going to be taking logarithms of negative numbers. If you try, you're going to get an error. Try to take the log of negative 3. Well, see how it says I? It's an imaginary. Okay, it's a complex number. If you put your calculator in reals, don't use imaginaries, it's not going to be able to do the problem I just typed in. It says error. Okay, it's a non-real answer. It's a complex number. So we're not going to be taking the logs of negative numbers, nor will the base ever be negative. The arguments in the bases will never be negative. Okay, you might be wondering, why did they use ln? What does the ln really stand for? Okay, it stands for natural log. Why don't they write it NL? Why don't, instead of ln? I don't know. That's just the abbreviation they use for natural log.
Could you like maybe scroll up a little or make that like a full page?
Okay, so as I said, this is one of 2 special logs. Natural log is 1, okay, when the base is an e. Okay, any question on that? All right, so let's try the same thing we did before, writing something as an exponential expression. But now I'm using our new abbreviation, ln. What you have to remember about the ln is it's hiding the base. You just have to remember what the base really is. Okay, so keep that in mind. The ln hides the base. It's there, but you can't see it. So what I like to do, if I'm going to do a problem like this, the first thing I'll do is take, instead of writing it out the short way, I'll write it out the long way. So then I can see the base easier. Writing ln, what's that the same as writing? Log base e. The 2 equations I have on the board right there, they're identical. Except now you can see everything. Base, argument, and what's going to go by, that's the 8 by itself. Okay, so I just said a second ago, e, that's my base. Adam, what's my exponent here?
8.
Yeah, 8. And what goes by itself on the other side? Go ahead.
X.
X. Okay, so this step from here to here, of writing it out the long way, you don't have to do that if you can remember the base is e. E is my base, 8 is my exponent, x is what goes on the other side. Okay, any questions on writing a natural logarithmic expression as an exponential? That's what we just did. Okay. Does everybody have the page on the left? All right.
What was the answer to the last one?
The answer, e to the 8th power. So we could type that in. could type in e, 8th power, and hit enter, and see what you get. We don't need to for this problem, though. Okay, without rewriting this one out using the long version of ln, anybody tell me what's my base, what's my exponent, and what goes on the other side? Yeah,
E to the power of 12 equals x.
that's it. So it's like the number 2.718 to the 12th power. That's the answer. Okay, generally, if an answer starts to get really big, like let's say the answer was in the hundreds or millions, I would just have you leave it as an exponential. E to the 12th, it's big, but it's not that big, 162,000. But it's probably big enough that I just say leave it as an exponent. Don't write it out. Okay. If I'd like it written out, I'll put that in the directions. All right. So the second type of special logarithm is when the base is a 10. Okay, this one comes up a lot. Okay. Because it's used so much, they call it the common logarithm. Common logarithm. So anytime you see something like this, what they're asking for there is what is the common logarithm of 8? Right? In other words, what's the log of 8 if you let the base be 10? So base 10 is common log. Okay, there's another one. Here's another one. What do you notice the difference between those two expressions? Yeah.
One has the 10, one doesn't.
Right. One has the 10, one doesn't. When you're working with a common log, you don't need to write the base. If you ever write the word log and you don't put a base in, we assume the base is a 10. Okay? It's kind of like if you write x. There's a number in front of x. There's a coefficient here. It's invisible, but it's there. Okay? You can put it in if you want, or you can leave it off. It doesn't matter. Okay? Same thing with this. Same idea. You can put the base in if you want, or if you don't put it in, we assume the base is a 10. Okay, so if the base is not written, you assume it's base 10. And your calculator does it exactly the same way. So I'll bring up my calculator. If I just press log, type in a number, and then I'll hit enter. To log of 25. Okay, it gives me the answer. Now, if I type it in as base 10, log base 10 of 25, it's going to give me the exact same thing. Okay, there's no difference. So, natural log, base e, common log, base 10. Those are the only two special ones we need to know. And you might be wondering, well, what if I don't have a calculator where I can type something in like that? Maybe you have a scientific one, and you can't type in a number for the base. Well, we'll deal with that probably tomorrow or Wednesday. But you don't need a calculator like this to do logs. It's handy. It's a little shortcut. If I want to do base 7, all I have to do is type in a 7 for the base. Scientific calculators, most of them don't have that. Some might, but a lot of them don't. Okay, so here's another equation. Solving this equation, you can really break it down into two parts. There's the part that I just taught you, the logarithm part. And once you deal with that, somehow you get rid of the word log there, which we've talked about. If you can get rid of it, then this becomes an algebra 1 equation. Okay? So let's see if we can get rid of the word log. What's that other way we can write it? Instead of logarithmic form, we can write it how? Exponential, exactly. So to solve that, we're going to change it from what it is now, log form to exponential. One reason we're going to do that, it's the only thing we know how to do. I haven't taught you how to do anything else yet with logs. So let's try that and see if it works. Okay, first thing you should do is identify your three parts. Here's your base. All of that is your argument. And that's by itself on the other side. Okay, so let's start with my base. Emily, what's my base here? Go ahead, what is it? 3, yeah. 3 is my base. What's my exponent? 2. So we get the 3, the 2, and what's the only thing left that can go on the other side? That's it. Now from here, you just do out your arithmetic and solve for x. Shelby, 3 squared gives me 9. Okay, Owen, what's my next step to get x by itself? Add 7. So that's going to cancel. And what will that give me for a new equation?
16 equals 4x.
Good. 16 equals 4x. Last step, divide by 4, divide by 4. And Tom, what do I get for x? What is it? 4, yeah. 16 divided by 4. Okay, so once you deal with that logarithm part, you get rid of the logarithm, then it's basically algebra 1. Okay, so that's why I said this week would be more like algebra. Hopefully an easier way to end the chapter. Okay, try that one on your own. Now it's a little different. Okay, in the one we had up above, the variable was in the argument. Now the variable is in the base. But I guarantee you the way you solve this is something you also learned in Algebra 1. So a little different, but similar. Okay, so give that a shot. See if you can change it to get rid of the word log first, and then solve it. Okay, so first thing we'll do is convert it. X is my base. 2 is my exponent. 64 goes on the other side. Now you can't add, subtract, multiply, or divide here. That's not going to get rid of the exponent. What do you do to both sides to get rid of an exponent of 2? Nope, not square it. Square root it. Yeah, it's already been squared. We've got to undo squaring, so square root. Is that what you meant? That symbol? Yeah, so square root. Take the square root. Square root cancels square. And square root of 64 is what? 8. What else? Negative 8. Okay, when you take the square root of a number, you get 2 answers. 8 times 8 is 64. Negative 8 times negative 8 is also 64. But what did I say about having negatives in the base? Do we do that? Yeah, we're not going to have negatives in the base. We're not going to have negatives in the argument. So don't worry about writing the negative answer. Just x equals 8. Okay. Any question on that one? Okay, let's try one more. And then this will be our last one. It says e to the 2x equals 5. Is that in exponential form or log form, Ben? That's exponential. Okay. So we can't solve it written like that, so we could try changing it to log form. Okay, let's see if that works. Ben, can you do that for me? Tell me, what's my base?
Your base is 2.
E, yep. My base is E. Logarithm always equals the Josh, do you remember that? Logarithm always equals
The exponent?
the exponent? Yep, good. Which in this case is what?
2.
More than that.
2x.
2x. That whole thing is up higher than the e. Sarah, what's the only thing I haven't used? 5. Okay, so now we need to solve that. Anybody see anything there we could simplify a little bit? There's something written the way we normally don't write it this way. We can shorten it up. Yeah. That could be changed to what? ln. Okay, so now we can type that in the calculator. I'll show you how to in a second. But I need to get rid of this 2 times x. Okay, so Olivia, how would I bring the 2 to the other side? Yeah, just divide by 2. So x is the natural log of 5. Divide by 2. Okay, here's how you type it in. Natural log 5. Make sure you close parenthesis. Divide by 2. It's about 0.805. Now, if I don't close the parenthesis, let's say I type it in like that, am I going to get the same answer? No. What it's doing now is it's taking the natural log of 5 divided by 2, or 2.5. It's not what I wanted to do. I wanted to take the natural log of 5 first, and then divide by 2. Okay, so be careful with your parentheses. Okay. Any question on that? All right. Okay, so the homework on logs, it's on 473, and it's all evens. Okay, 10 to 16, 22 to 28, 34 to 38, and 92 to 98. Okay, all evens.
Do you have an extra book that I can use?
Yeah. Okay, so you got a little over 15 minutes. Okay, so please try to get started on that. If you have any questions, I'll come around and help you out.